In this lesson, we're going to look at how to solve an equation using the wave function. So firstly, the question is really this. Solve root 3 cos theta plus sine theta equals negative 2 for theta is between 0 and 360 degrees. Now when you see an equation like this, we've got a cos theta and a sine theta, it's impossible to solve this without doing the wave function at the moment. We can't use the double angle formula because we don't have a cos squared, and we have no other option but to try and change this into the wave function format. So look out for it. If you see an equation like this, there's a cos plus a sine or a takeaway, you should be thinking wave function. Quite often the questions lead you into it. They'll say write it in the form k cos x minus alpha or so on. Sometimes they won't, and you have to be able to do it yourself. So firstly, I'll just get rid of this. Same idea as before, I'm not going to go through all this again. Multiply your addition formula out and get to this point here. Then look at the coefficients. So k cos alpha, that's the coefficient of cos theta. We'll look up here, and that's root 3. We're going to ignore the fact there's a negative 2 here. We're just going to get this side into the wave function format. So k cos theta is root 3, which means cos alpha, k cos alpha, sorry, is root 3, which means cos alpha is root 3 over k. We'll then look at the coefficient of sine theta. So k cos alpha is equal to 1 up here. If you look at that wee bit there, that'd be a 1. So sine alpha is 1 over k. Same as before, opposite over hypotenuse, that's your opposite. It's going to be a 1, hypotenuse is k. That's your adjacent over hypotenuse, so that's root 3. And your alpha is here. So Pythagoras, square root 3, square 1, and square root it. So you end up with 3 here, and 1, so 2, square root of 2, square root of 4, sorry, is 2. So that's the first part. We've worked out the value of k here. I need to find my alpha next. So same as before, I'll repeat this down here. Now, in this case, both are positive. So we tick where cos is positive, and that's A and C, and sine's positive, and A and S. So we're looking at a first quadrant answer here. So, looking at my triangle, this is tan, opposite over adjacent, so 1 over root 3. Find your relative acute angle, inverse tan, 1 over root 3, and that's going to be 30. It's an exact value. And that's our answer basically, because we're looking for the first quadrant solution. So we can rewrite this here, root 3 cos theta plus sine theta, as 2 cos theta minus 30 degrees. That's the first part on how to solve the equation. But we have to remember that all of this equals negative 2. So the second part of this, we're going to deal with that. So from the original question we had that, but I've just worked out that this can be written as 2 cos theta minus 30. So I'm going to replace that with 2 cos theta minus 30. Now this looks more likely to be able to solve. I've got a cos and there's no sine. I've got some numbers and I can undo this really to find what theta is. So divide by 2 first. You get negative 1. Inverse cos negative 1. If you look at the graph, then negative 1 appears at 180. And finally, to get theta, add on the 30 and you get 210. And that's your answer.